Welcome back to our new series on PCB design topics, and thank you for tuning into this discussion on manufacturing knowledge and PCB design. Here with me today are two experts in the field, Vernon Winnick, Technical Marketing Engineer for Expedition, and Max Clark, Product Strategy and Technology Director, whom both are with Siemens. Thank you both for joining me today.
Thanks, Stephen.
Thanks, Steve.
Awesome. With that said, let's dive right into this exciting topic, especially when we're talking about manufacturing-driven design. So with that said, Max, I want to start with you, especially regarding manufacturing knowledge in PCB design. The first thing I want to discuss is primarily electrical requirements. Manufacturing and requirements today are taken into consideration, but are still taken for granted. What is your input on that, or what is your take on that?
Yeah, sure. Absolutely. That's still largely true today, although we've made a lot of headway, say, in the last several decades here. When these EDA solutions were originally created, the primary objective behind them was all electrical based. All the constraint manager systems that are out there today are really more interested in ensuring that the electrical characteristics of the designs are met. Things like impedance and perhaps there's some other characteristics such as thermal that are taken into consideration. But the actual manufacturing of the printed circuit boards or the assembly of the printed circuit boards is still a left shift out of their purview. So as a result, the manufacturing knowledge just isn't typically within these EDA solutions. And so within our area of interest, we developed systems that are manufacturing facing and take into consideration not necessarily the requirements of manufacturing from the designer's perspective or from the OEM's perspective, but the objective is to take the actual manufacturer's capabilities and left shift that into the designer's cockpit, so that when the designer is actually designing the board, he's not only taking into consideration the electrical characteristics of the design, but also what their manufacturers are capable of producing. This is a monumental step forward for many companies out there, where they're used to having a lot of TQs turning around a design and a revision. We have this problem, we have this problem, we have this problem. When you left shift the manufacturing capabilities into your design process, it virtually eliminates or greatly minimizes those types of iteration. Even in your own personal experiences, knowing how many times a revision has occurred, not necessarily because it didn't match what the desired outcome was, but the producibility of the product was so poor that you elected to make a design change in order to improve upon the manufacturability of that product.
Vernon, I mean, you and I have discussed it in many a times where, it's amazing how our careers have evolved and how important, as we got deeper into our career, that knowledge of manufacturing has to be implemented at the point of design. Add your comments or give me your thoughts on that too.
Over like Max says, this has been decades long upcoming. But, when we started, in this industry years back, we worked to get the design hooked up, placed and routed. That was the most important thing. In fact, and we may talk about it a little further, discuss a little further into this, webcast here. But most designers have never even stepped inside of a manufacturing facility. So they don't know really what is required to build a board. Anybody can hook up, like we were, the old adage is, I can easily hook up 1 mil lines on a board, but a 1 mil trace can't be manufactured. And most people will not understand that from a manufacturing standpoint as to why. And I guess that would be one of my comments for the manufacturing tools that are left shifting into the designer's realm is, how do these tools educate designers that know nothing about manufacturing? How do they educate them other than, we've used in the past checklists and Excel spreadsheets and things to check our boards, But how are the tools now automating that for the designer so he doesn't have to rely on manual effort to check for these manufacturing items? So,
Exactly. I can tell you from experience, that there are a lot of times where during the process, the heat of the project to get the data out into fabrication, those processes and those checklists are ignored because it's all about, muscle memory and hey, I got to do this. I got to generate this output. I got to get this done and get it out. And you're not following the process. It breaks down because you're rushing to get stuff out. And, that leads me, to my next, topic I want to discuss regarding, moving, the paradigm from, DFM to, MDD, manufacturing driven design. Max, can you, walk us through that?
Yeah, sure. So when I first entered into this industry, I was in the fabrication and then the assembly realms. And we had what we call DFM there, design for manufacturing. And when I think back about it over the years, I think of it as not necessarily design for manufacturing. It's already in manufacturing. So quite frankly, it's too late to be designed for manufacturing. I really now, when I hear DFM, I really think of it as I'm going to manufacture this despite of your design. Okay, that's my purpose for DFM if I'm a fabricator, is I want to figure out a way to manufacture this despite what you sent me, okay? I'm going to try to minimize the amount of, because you're my customer, I want to try to minimize the amount of pain that I provide back to you. So when we started moving this within the Siemens realm into our Expedition product line, we didn't want to call it DFM because that's kind of been a hijacked name in a way. It's not necessarily something that people could currently view as a post-process, unfortunately. So we came up with this concept of manufacturing-driven design, and I wrote a book about it on I-007. And basically what it does is it engages the manufacturers early on in the process with the designer. We enable the manufacturers to implement their manufacturing capabilities into an online platform that the Expedition DFM tool then has the ability to access. And when the designer elects to make that decision, not only does the tool have the ability to perform the analysis based upon their manufacturer's capabilities, it also provides them guidance. So like when there is an issue, it just doesn't say, this is the problem. A pictorial comes up with an explanation on what the issue is. Because as you said, Vern, many of these designers have never even walked into a facility before. And so to just give them a list of concerns, it becomes frustrating. So now when a designer takes the time to utilize MDD, they can see that these are the results that we're finding. These are the needs that the manufacturer would like you to address, and then a pictorial with an explanation on why. And that's to help left shift that knowledge into the designer space, as opposed to just running what is typically referred to as a DFM solution. So MDD, that's what MDD does for you, and that's a differentiation.
yeah, and that again, Max, that's a very good process because, like you said, not only left shifts, but it creates this. Expedition's always been known for its correct by construction technology. So I'm starting out with the answers. I'm not waiting till that 3 o'clock in the morning phone call from my fabricator in China that says, "Hey, we found a problem in your board and we can't build it."
Sure.
And then you have to go back through this whole process again. I want to get to that process so I don't get those calls at 3 o'clock in the morning and my board gets built, with no X outs, full quality, and because the less quality I build into the board manufacturing wise, the more the board costs me.
Sure.
We all know that.
Exactly.
Sure.
This whole idea of, I can design anything. Well, that's great. There are boards houses out there that can build anything, but they're going to charge you for it. So
Yes.
Exactly. Max, you mentioned that book by that ebook that you made for iConnect 007, which is manufacturing driven design. that is an excellent book. And for those out there, I would highly recommend going and downloading it. It's a great resource. And Max does a great job at walking through the steps and showing you the advantage of implementing that. And I can tell you from decades of experience that it's very important to understand the impact of your engineering decisions at the point of design and how they ripple downstream. And if you were just throwing garbage over the wall, you're going to get that. You're going to get garbage back. You're going to get delays. Delays are cost. Everything increases. And in the evolution with today's engineering schedules and limited budgets and resources, you got to do it right the first time. And, a lot of times you don't get a second chance. So it's very important when you're talking about that collaboration. We recently published an article in the 007 magazine regarding, speaking the same language, with the supplier and the designer, between the fabricator and the designer, and how important that is. And, Vernon, I love the fact that you point that out, that most, not just designers, but most engineers have never walked through a fab shop. And so when I talk about all the minute details that go into design, it's amazing how many really just don't know.
Yeah, our design, and we talked about this in one of our other casts, that we are so multifaceted as PCB designers. We got to know so many things. We don't just need to know how to route and place a board. We need to know how to constrain a board. We need to know how to manufacture a board. We need to know how to assemble a board. And I'm sure at some point one of these podcasts will come up on assembly issues that are the same as fabrication issues. These all need to be left shifted. And this is something that a PCB designer, although you don't need to be a manufacturing expert, you need to know something about what you're doing and what you're providing, or what, like you said, throwing over the fence. I don't want to throw something over the fence to the next guy that he just has to ask all kinds of questions. Or maybe, in some cases, if you've dealt with the wrong manufacturer, where they won't ask the questions, they just move forward and build the board, and then you end up with trash. So, and it just costs money and costs time, like you said. So, we, with this multifaceted capability we have in this technology, this, as a PCB designer, we have to learn more. And I guess that would be my question for Max, is these manufacturing driven design tools are being made. What are they doing? What does the future look like for being a better training mechanism for PCB designers in the world?
Sure. So as we begin to gather this information from the various manufacturers, obviously we learn a lot about trends. There are about trends in the manufacturing space. You can actually do things like compare and contrast different manufacturers' capabilities. The challenge is that the individuals, from my perspective, the more time that goes by, the fewer and fewer designers are actually going to be inside these manufacturing facilities. And there's going to be less and less of the individuals coming from manufacturing and becoming a manufacturing engineer. That's usually the trend, is the manufacturer engineer comes from the manufacturing engineer working for an OEM, comes from the manufacturing realm. Yeah, I think they're going to see less and less of that, because if we're seeing this kind of pressure in the design space, they're seeing that kind of pressure in the manufacturing space too. And gathering that knowledge is going to be harder and harder. So what I anticipate is happening is, as we get designers and we focus more and more on what the designer's responsibilities and roles are, we're going to have to come up with applications and perhaps use of AI to assist the engineer in understanding more and more about what the issue is. And eventually, I'm sure that there'll be a period of time where AI can actually make suggestions to the changes in the design itself in order to improve upon the manufacturability of the design. I think we're a little ways from that still. Right now we're just trying to get things like auto routers and stuff like this to work. And of course, that's going to come with its whole new realm of manufacturing challenges. But eventually AI will play a role in this space. I think it's a little premature. There are other solutions out there that are trying to achieve this left shift. the shortcoming that those tools typically encounter is they typically try to apply the same electrical set of rules with the idea that their manufacturers are somehow going to populate that. But their paradigm is flawed because if I'm a manufacturer, I make a layer. I'm not concerned about the nets. I have to be able to produce the whole layer. And so these constraint managers tend to come at it from a different perspective than a manufacturer has to. Go ahead.
I was just going to say, could a constraint, you like you said, AI could be involved, but I could see where a constraint manager, where a PCB designer like myself may say, I'm designing a board with 3 mil lines,
Sure.
and AI would then look at the manufacturers that you have used in the past and
Absolutely.
say, you don't have a manufacturer that can do 3 mil lines.
Right. That's the compare and contrast that we were talking about earlier. The ability to, the more and more these manufacturers that come on board with MDD, the more and more of that we can typically do. It is important to make sure that the manufacturers do understand that one thing MDD does, which is their dream, is encourages their customers to engage with them earlier, because what they're going to end up doing is putting up available their manufacturing capabilities, but they know they can do better under certain circumstances, right? Or maybe they know they can do it, but they're just going to have to charge you a little bit more for it. So they can, in the true MDD environment, you can release the capabilities to an individual or to a company, so that you and I can work together, and you can say, Max, I need to have a 3 mil annual ring, and I go, Vern, we can make that, but our yield's going to suffer. You say, I don't care. I got to do this. I'm in a bind. I can go out, create what we call a DFM profile that has that change in it, and release it just to you. So just you. That way you aren't getting all these false alarms in your analysis results, but you and I now know that, this board is going to have some additional costs because I'm going to have a yield issue that I wouldn't typically have. But at least we've agreed up
Yeah,
front.
and like you said, this is something for all PCB designers listening to know, is this is the key point, is to get involved with your manufacturer right at the beginning of your
Exactly.
design.
That's what this encourages them to do. This whole MDD encourages them to do. And then you don't have to do things like, you talked about 3 o'clock in the morning call. One of the things I really disliked about a 3 o'clock in the morning call as a fabricator is when if you said, you know what, Max, I'm going to send you the Gerber for a layer 3.
Oh,
What I want you to do is delete yours and send me and then replace it. We do it, but I really didn't like it, because if somehow something ended up screwed up, it's going to be on us. And,
I can tell you right now, yeah.
This leads to all the design data format type of issues that people have today in just trying to make intelligent exchange of information. It's crazy. Absolutely crazy.
Yeah, I would tell you, Max, I couldn't agree with you more. It is not good practice if you get a technical query to send partial data to your supplier, because, from my experience, especially with a lot of the leading, fabricators, they've got to start over. You give them the data, they got to start. They got to start over from the CAM process all over again. So, and in most cases, especially like in the mil-aero industry, you can't just release a piece of the data. You've got to release the entire data again, the whole package. And you're talking a ripple effect. And this is why the costs go through the roof, because just to make a typo change, it's extremely expensive to go back and make the change. And not just make the change, but now you have to do a root cause corrective action to figure out, why did you make the change? How do you implement so you don't ever make, have that error again, or that issue to happen again? And it can be extremely expensive. And I think, the issue we're dealing with today, and Vernon, you and I talked about this in our last discussion, of the skills gap that's happening in the industry, where you got a lot of engineers coming out of school where most of the designers have no education on designing circuit boards, but yet they're tossed into the fire and say, hey, we need you to design a board. And they have no concept of what exactly goes into making a board, which leads me to our next discussion, or our next topic I want to cover is design data formats, so Max, I mean, what is your take on that? I know you discussed that heavily in your book, so we'll let you start off with that one.
Right. So, it's kind of interesting. The whole idea started back in '95 when the idea of trying to eliminate these unintelligent, unconnected pieces of data together, as we just spoke. I just spoke with Fern about sending me one Gerber layer all over again. These were disconnected pieces of content, which made it possible to do. We never would like to have done what I just suggested, but believe me, we all know that it has happened in this world. So, ideally, what we'd like to be able to do is to send a file, send a file, a container that contains all the data to be manufactured. So currently, there's Gerber. Gerber still is the primary means. Probably 50%, 60% Gerber, something like this. But there are two other formats that are out there. One's ODB++, which was originated in '95, widely accepted by virtually all manufacturers at this point, and used by large OEMs. There's another format, IPC 2581, which is from a committee. There's challenges, just like with ODB++, it wasn't accepted overnight. Changing formats and converting entire solutions, entire release processes around those are not a simple thing to do. The ODB++ has the second largest acceptance rates, and part of it's because the format's stable. It's been around for a while. It contains what people really need in order to manufacture. 2581 is a good idea. It's run by a committee, and so the challenge there is it tries to be everything to everyone, and that's always a challenge because you never do. It's like a jack of all trades. It does everything but nothing real well. So that's going to be a challenge for the upcoming period of time as this format begins to try to find a home. Because I can tell you, as a developer having to rely on that format as a data source or export as a data source, the amount of change that it goes through and its backwards compatibility issues make it very challenging to use. Where ODB++ is very reliable, it's robust, it generally is accepted, and I promote that format because I believe in it, and I know that it has a proven track record. You probably can't you probably can never own a piece of electronic equipment in your house that's not been exchanged in ODB++. 2581, on the other hand, you probably would have to look for it.
When I think about the three main data formats, I mean, I Connect 007 back in October of 2021. They spent a whole month, a whole publication series regarding a monthly issue on that in October. Of all they discussed was the different formats and the different advantages and disadvantages that they bring to the table. And they did this earlier back in 2014, in September 2014. And you can go to their website and look at and recall these different publications and really dive into the details of each one and see. And it's amazing to see the evolution, but yet, how things are kind of lagging. And the old saying is, if it's not broke, don't fix it. So this is why you'll tend to see that Gerber data is still, the highly sought after one, because everyone's okay with it. And I know there's push to go more intelligent, but in the end, it's all comes down to what you agree with you and your supplier, and what is your engineering intent? What are you after? What is your end result? And that's a collaboration. This is why, Vernon, you made a great point earlier in the discussion today, is that your manufacturer should be a key stakeholder at the beginning of your project. And it's got to be right there at the table from the very beginning, whether it's fabrication or assembly. They've got to be right there and have their say. So that way, when you think of, handing off data, it's like a relay race. You want to be able to hand it off in the most optimal way, hand that baton off or hand that data off in the most optimal way. So there are no friction or no stoppages, when you're going from engineering to fabrication to assembly. So it's really a struggle in that. And many people they have struggles today. I mean, Vernon, you can add to that.
No, that's, one of the keys, we talked about this in our first podcast, is that, one of the keys to being a good designer today, and we want to bring good designers up into the world today. That's one of the things we've been talking about, is the next generation of designers. One of the keys to being that good designer in the world today is knowing who you affect down the road. There's so many people you affect, from engineering to manufacturing to assembly to the people who build the box that the board goes into, to the people using your product. You need to know how you affect these people, and that needs to be driven left into your realm so that you can intelligently make decisions to be correct by construction, so you don't have to do these things over again. You don't get the 3 a.m. phone calls. You don't, have a problem where you can't build a board, and ultimately you don't have a board that may affect the end user, adversely, because of your design. So.
Yeah. Vernon, can you elaborate a little? Because I know we're running close to time here, our time budget, but I want to at least cover education for new designers. We've got to, have a brief discussion on that. We can't let that go. It's so important.
So, on this subject of manufacturing, one of the things that I do with educating designers in the field, and what I think is something that we need to continue to do in the field, and I know you do some education in classroom and everything, and it's one thing I like to do is I take people on field trips. I remember the old field trips when I was a little kid in school. Well, I take designers on field trips. I take them to board houses. I walk them through the board house, and I have the manufacturers explain every step of the way so you can understand how your board is being built along the way. Because the more you know how your board is being built, the more process that you can put into your design process. This is one of the education techniques I use today. I'm hoping that we can get to a level where maybe we can work with manufacturing houses to train printed circuit board designers virtually, maybe virtual design tours, AI type capability like Max spoke of, that when I make a decision in a printed circuit board design, maybe AI comes up and says, maybe you should watch this video because you're doing something that you shouldn't be doing. And and I think that's where we have to get in this world today. We have a problem with the number of designers that are going to be in the field in the future. We need to rebuild our family of printed circuit board designers, because old guys, dinosaurs like me, we're heading out soon. We need to get those new guys trained, and part of training them is going to be this whole manufacturing thing. And I'm sure in the future here, like I said, we're going to talk about assembly, we're going to talk about analysis, we're going to talk about everything. And it all falls under our hat that we have to wear. We don't need to know everything about it, but we need to know at least enough to build a board properly or design a board properly.
Excellent. I would tell you, the different associations that are out there, in different sources to get education, whether it's Design 007 magazine or PCDNF magazine by PCA, it's amazing. From PCA Association to IPC Association to SMTA, IEEE, there's a lot of industry associations that are helping educate the industry. But in the end, they'll put the water in front of the individual. The individual has to drink it and then apply it. That's the key.
I think the plan was we'll put some links in these podcasts, and these things you're talking about, these magazines that are available to us as PCB designers, they're free. Go in, sign up. They're
amazing
very
content.
educational.
Amazing content.
Yeah, it's a lot of content that we can really take, and it's people like myself and Stefan and Max in the industry that we write articles in these things all the time that are good information for a circuit board designer to know.
Yeah, Max, is there anything you'd like to add before I wrap this up?
No, I think I would encourage designers to get more and more interested in MDD, DFM, MDD. I would encourage them to try to do as much of this analysis as early as possible, and to engage with their suppliers early on and set the expectation that you are expecting this type of collaboration. It's not just a matter of me sending you the design when I'm done and you telling me all that's wrong with it. I would like to be able to determine that as early as possible in the design stage so that I can end these TQs and end these 3 o'clock in the morning, telephone calls. That's my dream is to be able to put an end to all of those, all those interruptions, which is really what they are, is interruptions in production. And that would be my ask of those listening.
Yep. Build it into
Awesome,
your
awesome.
workflow now. So
Correct by construction. Exactly. Well, I think we need to wrap it up. It's been a great discussion. And I want to thank you both, Vernon and Max, for joining me today in this discussion regarding manufacturing knowledge and PCB design. Make sure you join us for further discussions on future discussions on and presentations regarding, industry content.
okay. Thanks, Stefan.
Thanks, Seth.